Good afternoon to everyone. In today's class, we are going to see how to write an answer for a question. Because the main problem right now we are facing is we know the concept, but we are lacking behind how to give our 100% presentation in the paper. Okay, here I'm taking a sample question, that is state and explain Kirchhoff's law and state its applications and limitations. The same answer can be given for one more question, that is explain about KVL or KCL, whatever the law they ask individually with an example. So if you prepare one question, you can give your answer for these two questions. Okay, but you should prepare elaborately and in with example you need to prepare. So here uh, just I'm giving my answer. So we know that we have two different laws in our Kirchhoff's law, that is KVL as well as the KCL. So the KVL states or the KCL states whatever the current at a junction, whatever the incoming current at a junction should be equals to the current leaving at a junction. So the first point I mentioned it is whatever the current flowing towards the junction, whatever the current flowing towards the junction, it should be equals to the current leaving the junction. So the same point what I stated, the sum of the currents at the node, the sum of the currents at the node, it should be equals to the 0. So to highlight my answer, I just provided within highlighting within a box. So instead of going these two paragraphs, if he simply sees this box, he came to know the current at a node is equals to 0. So I'm just giving the notations of the current. So at the node or junction, the incoming current is considered as positive, and while leaving the current as negative. So to explain this one, I just considering a simple circuit and I provided the notations. And provided the notations here. So which are the positives and which are the negatives here. So here the current I1 and I2 are towards the junction, so it will be considered as positive, while I3 is the leaving current, so I am considering it as negative. Okay, so the same thing I provided here, and with this the incoming current is equals to your leaving current I mentioned. So whereas coming to the KVL, we know the whatever the voltage drops in a closed loop is equals to 0. The closed loop is equals to 0. At the same time, the drops in the closed loop should be equals to the voltage rises. That's also we mentioned. So I just highlighted my point with whatever the voltages in a closed path, the sum of voltages in a closed path should be equals to 0. I just highlighted, and here I am giving the notations. The notations for voltage drops, this is for voltage drops. Whatever the current direction, that means the way we are traveling, the path we are traveling in the resistor is same as to your current direction. We are considering it as a fall of the current, and the notation is negative. If it is opposite to your current direction, then it will be a voltage rise and it will be considered as positive. Kindly remember, this is for voltage drops. Similar fashion for voltage rises. If the path traces from positive to negative, we are considering it as a fall of the voltage. Then the sign of your voltage rise is negative. Similar fashion, if it is travels from negative to positive, we will considering it as a rise in voltage, and the signature will be, the sign will be your positive. To explain this notation, I have just provided with a simple circuit considering this one, and the current in your circuit is I. So it is travels in the direction where how you are going travel. So from this direction. So here we are traveling from negative terminal to the positive terminal. From negative terminal to positive terminal I am traveling. So as per my theory, the sign of your voltage rise, is positive. Similarly, if you are considering the notation, the path is same in the direction of current, the voltage drop notation is negative. The same thing I mean explained here. The signature, the sign of your voltage is positive because it is traveling from negative to positive terminals, and the sign of your V1 and V2 are negative because it is the same as the direction of your current. Okay, when I apply this, so whatever your applied voltage is equals to your drops, as per my theory. Okay, so to explain this both KVL and KCL, instead of going with the two different circuits or two different numericals, I just go with a simple circuit. Kindly remember, I just want to explain what is the proof for the KVL and what is the proof for KCL. That's it, my notation is. So I'm just considering a simple uh, two loop circuit. So this circuit having two loops, this is loop 1 and this is loop 2. Because why I'm considering the two loop circuit is because to explain my KCL I just need a node. So I need a node, so that's why I'm going for the two loops. Okay, when I observe these two that means these 2 ohms resistors are in parallel, and this combination is in series with 5 ohms resistor. So I'm totally find out what will be the total resistance of the circuit, and from that as per the Ohm's law, V equals to IR, I find out what will be the total current. That means the current from your 30 ohms source is 5 amperes. So because of this current there will be an voltage drops across your circuits. So first of all we need to calculate what to verify your KCL. So up to this node the 5 amperes current is appears. Once node reaches, the current have two different paths, the current need to be divided. So for ease of my calculation, I am considering these two resistors are equal in proportionals. That means the current will be divided in equal parts. Anyhow, I am calculated by using the current division principle. So opposite branch resistance divided by total branch resistance. So total current multiplied by opposite branch resistance divided by total resistance. So I got it as 2.5 because opposite resistance for any branch it is 2 only. The total resistance is combination of these two. So anyhow I am getting 2.5 amperes. So the sum of, when I observe here, this is coming towards the junction, these two are leaving the junction. So incoming current should be equals to the outgoing current. That means I1 should be equals to the I1 plus I2. I verified the answer. That is 5 equals to 2.5 plus 2.5. It is another 5. So 5 equals to 5. Your KCL is verified. To verify your KVL, I just one loop is more than enough with a source, because I need a source because this is a voltage rise, these are the voltage drops. So to find out your voltage drops from your Ohm's law, V equals to IR. So I find out the Ohm's law. Here the current is 5 ohms we seen from our previous thing, and current in 2 ohms resistor is 2.5 amperes. So I find out what will be the V1 and V2. So when I add V1 and V2, I got 30, which is nothing but my applied voltage. So with this, the applied voltage should be equals to your voltage drops. So V equals to V1 plus V2. Your KVL is verified. Whereas coming to your applications and limitations, to analyze your circuit, whether it is an electrical or electronics, you can go with this KVLs to find out your voltage and currents. That is your application. Whereas coming to the limitations, this is only applied only for your lumped elements. That means if the resistor combination, if you are considering it as a lumped one, that means if here it is this portion, this element, like that, it is not distributed throughout the length of the line, or like that, it is not be applicable. So lumped element, it should be sit at one position. So lumped elements, it will be applicable. At the same time, these Kirchhoff law are not applicable for the circuits which are having the fluctuating magnetic fields or charges, that is varying charges. It is not applicable. Only for the constant values it can be applicable. At the same time, it never includes for the higher frequency circuits, that is for your resistors, inductors and capacitors. So for not applicable for the higher frequency circuits. This is the way how you need to represent your answer as per the marks, okay, as per the given marks. So I hope it will be useful. Thank you.